we have 16 here. Okay, 18 minus 2, 16. And A inverse, okay, A inverse will equals to 1 over AD minus BC. And AD minus BC is determinant A, so we'll have 1 over 16. And we will change, like swap the numbers on the main diagonal, and we'll negative the number on the other diagonal. You will have that. Okay, so it's not necessary for me to times the 16 inside. Okay, it's not necessary for me to put the 16 inside. Or you can put 1 over 16 inside. That will give you, let's say 6 over 16 minus 1 over 16 and minus 2 over 16 and 3 over 16. And that will equals to 3 over 8. Negative 1 on 16 minus 1 on 8 and 3 over 16. Okay, you can keep your answer in this way out like this one. You can take a scalar out. Okay, you can take a scalar out. Okay, in C, if you have AX plus B equals to C. Okay, if you have AX plus B equals to C, and I want to solve for X. Okay, I want to solve for X. Okay, this is the important thing, the calculations, like the solving for matrices. Okay, if it's numbers, you will have AX equals to C minus B. Okay, calculate, like numerical calculation and matrix calculation will be very similar. So you can subtract the matrix first. You have AX equals to C minus B. Okay, the next thing is important. The next thing is important. Can you divide A? I can't do divisions. Okay, I can't do divisions of A. I can't do division of A. So what I can do? I can't divide by A, but I can times A inverse. Okay, I can times A inverse. What I'm trying to do to divide A, I can't. But I can times A inverse. But where do I put this A inverse is very important. So this A inverse will go next to this A. Okay, if you times A inverse in the front for the left hand side, you need to times A inverse on the in the top of the left hand side as well. Okay, can you see the position you put A inverse must be in the front. Okay, why I can't do at the bottom? Let's say if we put that at the bottom, in the bottom. Okay, so let's say we have AX and that times A inverse, and that will equals to C minus B times A inverse. Let's see the difference between those two. Okay, let's see the difference between those two. What you know is AB times together is not equals to B times A. Remember that? A times B is not the same as B times A. So when you have that, you can't swap the order. Okay, you can't swap the order. The order of the matrix multiplication is very important. So what I can have for this line? Okay, for the first two times together, A inverse times A, what that equals to? A inverse times A. Identity, right? A inverse times A is identity. So you will have identity for those two times together. Okay, and the next thing you want to times is the X. Okay, so just copy the left hand side. And what's I times X? What's identity times X equals to? What's identity times X? X, okay, still X. So just have X on the left hand side. Okay, so X equals to A inverse in the front times C minus B. Let's say if we times that at the back. Okay, if we times this here, okay, times A inverse at the back, what will happen? A times X, I don't know how large is that. X times A inverse, I don't know how large is that. Okay, so I can't put A and A inverse together. I can't see A and A inverse together. Therefore, this one doesn't work. Okay, this one doesn't work. So you should know A inverse times C minus B is not the same as C minus B times A inverse. Okay, they are not the same thing. So the A inverse must be at the front. Okay, A inverse must be at the front. So if you have this, if you have X times A equals to B, okay, if we have that, if you have X times A equals to B, so what you have is X times A inverse at the back. Okay, now you can times the inverse at the back. You want to put the A inverse next to A, but you can't put that in the middle. Okay, you can't put in between X and A. You can't put in the middle. So this side will equals to B times A inverse. And you can times those two together. I can't change the order, but I can time those two together. Therefore, I will have X times I. That equals to B times A inverse. And X will equals to B times A inverse. At this time, A inverse is at the back. Okay, A inverse is at the back. So it depends on where is your A. Okay, where is your A? And that decides where is the A inverse. Okay, so that's just another example I want to show into you. I'll just show you the importance of times A inverse at the correct position. So now in this question, I have X equals to A inverse. So A inverse is 1 over 16 times 6 minus 2 minus 1 and 3 times C minus B. So C is 3426 minus B. B is 4 minus 122. So X equals to 1 over 16, 6 minus 2 minus 1 and 3, and time with minus 1, 5, 0, and 4. Okay, 3 minus 4 is minus 1, 4 minus negative 1 is 5, 2 minus 2 is 0, 6 minus 2 is 4. And you have a scalar in the front. Okay, you have a scalar in the front. So don't worry about the scalar. You will have row times row, row times row, column, column. Okay, we have row 1, row 2, column 1, and column 2. So X will equals to 1 over 16. Okay, row 1 times column 1. You have 6 times minus 1 plus minus 2 times 0, which is minus 6. Row 1 times column 2. Row 1 times column 2. You have 30 plus minus 8. Okay, row 1, column 2, first times first, second times second, 30 minus 8. You have 24. That's row 1, column 2. Okay, it's this position here. Row 1, column 2. And row 2, column 1. Okay, row 2, column 1. Minus 1 times minus 1 is 1. 3 times 0 is 0. Plus together, we have a 1 here. And for row 2, column 2, you have minus 1 times 5. You have minus 5 plus 12. 3 times 4 is 12. So you have 7 here. So X will equals to that. Or you can put the 16 inside. Or you can put the 16 inside. That's minus 3 over 8. 1 on 16. 4, 6 is 4. Yeah. Which one? Oh, here, yes. 22 here. That's 22. Thank you. Next time, tell me earlier. So it's 11 on 8 and 7 over 16. Okay, that's how you solve for x in matrix. Okay, that's how you solve for x in matrix. That's just two comparisons with where you times A inverse. Okay, that's calculations for inverse. Okay, so instead of division, we will use times the inverse of the matrix. Okay, instead of divide the matrix, you times the inverse of that matrix. Okay, so let's have a look at two, not really two, that's only one application question. I'm not sure if you have learned this before, but like matrix can be used to solve simultaneous equations. Okay, let's add a line in the form of ax plus by equals to c. Okay, in the form of ax plus by equals to c. Okay, if you want to solve simultaneous equations, it must be in the form of ax plus by equals to c. It must be in that form. Okay, at this stage, we can only solve simultaneous equations with two variables. Okay, why with two variables? Because we only know inverse for 2 times 2 matrix. We don't know the inverse for 3 times 3. I will show you why. Okay, I will show you why. Let's have a look. You have y minus 4x equals to 3. So let's put that into minus 4x plus y equals to 3 because ax plus by equals to c. And the second equation I will have 5x minus 2y equals to 6. Okay, move the 5x to the side, move the 2y to the side, so it's 5x minus 2y equals to 6. Okay, 6 equals to 5x minus 2y, so 5x minus 2y equals to 6. Okay, so next thing what I'm going to write is set up a matrix. Okay, when you write this in the correct form, I can set up a matrix. So how we can set up this matrix is the coefficient, you write the coefficient in the corresponding place. Okay, minus 4, 1, 5, and minus 2. You can see that's already a square. Okay, just take off the xy. What you left is 4, 1, 5, minus 2. And then what you do, you times the column matrix xy. And that equals to 3, 6. Okay, that's how you set up this matrix. Okay, next thing what we'll do is solve for that. Okay, how do we solve for that? Let's say if that is matrix A, that is a capital matrix X, and that equals to a matrix B. Okay, so matrix A times matrix X equals to matrix B. What I'm trying to solve is matrix X, right? Is matrix X. Should I times A inverse in the front or times that at the back? Front, okay? Because A is here. I need to times A inverse here, times A inverse here. That will gives me an I, okay, identity matrix. And the identity matrix times X will just give you X. X will equals to A inverse times B. A inverse times B. So let's have a look at that. A equals to minus 4, 1, 5, and minus 2. So A inverse will equal to 1 over AD, which is 8, minus BC, which is 5. And you will swap those two numbers and you negative the other two numbers. And that gives you, that's a 3. I can go for a minus 1 over 3. And then I have 2, 1, 5, 4. I take out the negative inside the matrix. Okay, I take all the negative out. I put the negative outside. So x equals to negative a third times 2, 1, 5, 4. And times b. B is 3 and 6. The front one's row times second one's column. Okay. Row 1, column 1. Okay, row 1. Okay, this is a 2 times 2 matrix times a 2 times 1 matrix. Okay, 2 times 2 matrix times a 2 times 1 matrix. That will give you a 2 times 1 matrix. Okay, that will give you a 2 times 1 matrix. Because those two are the same, what you left is 2 times 1. Okay, that will give you a 2 times 1 matrix. So let's have a look. That's row 1 and row 2, and you have only one column, column 1. So row 1, column 1, which is 2 times 3 plus 1 times 6. 6 plus 6, which is 12. Row 2 times column 1, which is 5 times 3 plus 4 times 6. 15 plus 24, 39. And x equals to minus 4 minus 13. Minus 4 and minus 13. So what is x? X is xy. Okay, capital X is xy. Xy equals to minus 4 minus 13. Therefore, your x will equals to minus 4, y will equals to minus 13. Instead of substitution, instead of simultaneously solve linears, okay, instead of simultaneously solve for linears, I can use matrix to solve for this as well. Well, let's have a think for this question. Maybe not for this particular question, but for this type of question. You have a matrix A times a matrix X equals to matrix B, and you're trying to solve for matrix X. Is that a chance that you cannot find any value for X? That no solution for X, is that possible? Is that possible that there's no solution for this X? Remember, you times A inverse, okay? A inverse times B, okay? A inverse times B. If your A inverse doesn't exist, if your A inverse doesn't exist at all, which means you have no solutions, or you may have infinitely many solutions for this simultaneous equation. Remember, for two linear simultaneous equations, okay, simultaneous equations, you have two simultaneous equations, there are three possibilities. Single values, a unit value. If there are two parallel, no solutions. Or if they are the same line, infinitely many solutions. You can solve three cases. And the method we use at that time is we equalize the gradient and we equalize the y-intercept. And we compare those values and we say which case we have unique, which case we have infinitely many, which case we have no solutions. Okay, that's what we learned at the very beginning. Also, this question can be done by using the matrix method. Okay, this can be done by using the matrix method. I don't have enough time to go through this. I don't want to rush that. But I want you to go back to the previous question on page 13. I think I give you the notes the very beginning. Why you have page 13? Not this booklet, not this booklet, the very beginning booklet. The first one I give it to you on page 13. You will have a question like that. Or I think it's one of that question. We didn't really do that question at that time. It's a matrix question. I said I will come back to that later. So that's this question. Okay, that's this question. I want you to use your own method to solve for this first. Not necessary to be matrix. You can use the method we did before to solve for it. Okay, any method. Just solve for this question. And we'll go through the matrix method next lesson. I want you to be familiar with unique solution, no solution, and infinite many solutions. Okay, I want you to remember that. Okay, that is quite important. Okay, let's